Hello and welcome to the Energy News Biz webinar titled Introduction on TNO Activities for the Hydrogen Transition. My name is Arnes Biogradlija and I'll be your host today. We hope you'll be satisfied with what you learn here. TNO is the largest independent research and technology organization in the Netherlands. It has a wide portfolio of activities to support the hydrogen transition. TNO employs more than 3,600 professionals that work in multidisciplinary teams to develop innovative solutions at system level for complex transitions. During this webinar, Peter Paul van Veen, who is a business developer at TNO for Sub-Saharan Africa, will give an overview of the hydrogen activities at TNO and present several of the latest achievements. Thomas Hajonides van der Meulen, a hydrogen value chain expert at TNO, will tell us about work performed at TNO on hydrogen trade routes and the main drivers for the trade from the man perspective. Mr. Kal'air Trezeguet, who is the chairman of Hydrogen Africa, will take the stage first and tell us more about Hydrogen Africa and its connection to TNO. After all presentations, there will be room for some questions. Mr. Trezeguet, the stage is yours.
Thank you. Good morning, gentlemen. Good morning to all audience that are seeing us all over the world. It's a great day. It's a wonderful day. Yeah. Before I start my word, I say hydrogen partnership for all. Hydrogen attract all our living society. My name is Kal'air Trezeguet, a group CEO of TNT Corporation and the chairman of Hydrogen Africa. I believe once I say Hydrogen Africa, everybody understand about. We're only talking about African hydrogen. Hydrogen Africa is an association that was built to involve all the good head, people who have volunteers, people who have the passion of African development. So that's why we create Hydrogen Africa Group. To be based actually to support all kind of initiatives and projects when it comes to green hydrogens. And to be also on a mission, looking for investors, to be like the caterpillar of all investors, all stakeholders in Europe, in Asia, in America, in Australia. They're looking to go through Africa to invest in the green hydrogen project or research. We'll be capable to demonstrate and to tell them, here are the place to go, here are the people to meet, here are the kind of project, it's here where we are standing in terms of the cost, it's about the help, it's in terms of the research of the total research of green hydrogens. So that's actually our mission in Europe. We have our head office here in Paris, by Nijmegen in Paris, and then we have another office in South Africa, in Johannesburg. So, what actually we stand for? Hydrogen Africa, because we're looking, what can we build? We're looking forward to build the economic societies in Africa. We're looking to do energy transition of African countries. Everybody's talking about hydrogen in Africa. People are rushing to talk about Africa is the El Dorado of green hydrogen. Africa is the hub of hydrogen. But what the research has been done? What is the innovation that we are going? We need to have a proper research company and proper innovation companies. That was our mission. Before we go to finance, we need first to have an innovation company. Who can innovate once we have those monies? Who can innovate once our financial are there? What the research, what the next research? Because we talk about we are 2022, we are going to 2025, 2030 that we need to deliver. So my mission was to go to Europe, to America, to Asia, to look for potential partners that we know they're capable to deliver. People who are serious about the people not serious, but people who have passion for African countries. People who can do something. That's why we knock the door by TNOs. TNO's not coming now. TNO will come long, like 2 years now. We see all the ambition of TNOs. We see the kind of research TNOs are doing across the continent. That's actually was attracting us to say, TNO, we're carrying them to Africa. TNO say, guys, I will come to Africa and work with you guys where the potential of green hydrogen is. So that's exactly where we are, because, you know, sometimes actually what we talk about, It's about the environmental awareness of sustainability development on innovation that Africa needs. That's what we need in Africa. We need to build our socioeconomic. We need to do everything to involve our innovations. So TNO actually are working with us to all those kind of type of research. So we started with Namibia, and then TNO is now with us in South Africa. It's where actually we are working hand to hand to present TNO to all stakeholders between the public and private sector in South Africa to know that TNO is the right company. TNO is there to support the green hydrogen in South Africa. But our mission is to go to different countries in Africa. But we started first with the southern region. We know we have 9 regions, actually 9 countries that are their potential to produce and do the production of green hydrogen. But we live in Namibia, now we're in South Africa. Our mission for this year is about South Africa. So TNOs are accompanying us to building and pushing South Africa, as South Africa is the greater value of green hydrogen. So is that where we are? TNO will be with us to build South Africa green hydrogen until the top. And they will see here we are, because we left with few years to demonstrate green hydrogen of South Africa, to sell to the world that South Africa are capable. South Africa standing here to go, to move as the hub and hydrogen hub of the world. We talk about the global, we're not talking about Africa. That's where South Africa is standing for, because we got all potentials. We got sea, we have minerals, we have metal, we have everything that can produce the best of hydrogen in the world. Thank you.
Thank you, Mr. Trezeguet. Peter, the stage is yours.
Thank you, Arnes, and also Kal'air for the introduction and the kind words. And good afternoon to all attendees. So we very much as TNO appreciate to have the opportunity to share our work on hydrogen in this webinar. But let me firstly shortly also introduce TNO to you and my presentation, upload my presentation. So, as Arnes already explained to you, the TNO is, but I will go into somewhat more detail there. We are a not-for-profit research and technology organization in the Netherlands. We employ about 3,300 professionals in 2021, but it's growing indeed, and at the moment we are already 3,600. Our turnover in 2021 was about 570 million euros, of which 18% international. So we are located in the Netherlands, but we are active worldwide, and we were really also investing in Africa. And as Kal'air Trezeguet already mentioned, for us, hydrogen transition in Africa, we've seen the energy, we've seen the ambition, and we really would be very interested to contribute where possible and necessary. Our mission is to create innovations that boost the competitive strength of the industry and society in general in a sustainable way. So sustainability is really at the core of our activities. And we don't do that, of course, on our own, but we do that in close cooperation with the private sector, government, and knowledge partners. Our mission statements, to wrap it up, is to connect people and knowledge to create innovation that boost the competitive strength of industry and the well-being of society in a sustainable way. So let us first look at the task, and then I take the perspective of the Netherlands. The task we face in transforming our energy system, as we all know, is enormous. Only the necessary investments in hydrogen are already massive. And I would like to illustrate that by looking at the Dutch hydrogen strategy as it is presently unfolding. Yeah? It's also in the Netherlands developing very rapidly. First of all, we need electricity, of course, to generate hydrogen and renewable electricity. So in the Netherlands, we have the ambition to scale up offshore wind from the current 3 gigawatt installed power to 21 gigawatt by 2030. And this will be, indeed, this will be mainly offshore, as the picture also illustrates. In parallel, we aim to develop 3 to 4 gigawatt of electrolyzer capacity by the same time. So several projects are already announced, and the necessary landing infrastructure is also under development. But apart from local hydrogen production, we also will have to import hydrogen, that's clear. In reaction on the war in Ukraine, the ambition for import has been redefined and is now on a European level raised to 10 million tons of hydrogen in 2030. And the Netherlands is, of course, with its harbors and its infrastructure and as a gateway to the Western European market, is actively working on the development of export and import supply chains. The necessary infrastructure, such as terminals and cross-boundary connections, are prepared, as well as proper certification schemes necessary for trade and quality control are put in place. So, this is not the only thing, of course, that has to be done. We have a distribution system for natural gas in the Netherlands at present, but already a start has been made to transform part of our natural gas pipeline backbone into a hydrogen backbone. And this pipeline system will then connect the hydrogen production facilities and the harbors with the main chemical industry hubs in the Netherlands and even abroad. In order to manage this massive investments in hydrogen infrastructure in a responsible way, it is necessary to align supply and demand carefully over time. And for this purpose, a decision cycle between government, TSOs and industry is in place. With a central instrument, a roadmap for electrification and the shift to hydrogen for the Dutch industry as one of the main off-takers. And this is all, of course, backed up again by schemes for legislation and policies, regulation, and also, of course, safety programs and education. At TNO, we have developed over the past years a broad portfolio of activities to support the development of an hydrogen economy. So this picture illustrates that we are working with in about six different programs and development which are aimed at specific parts of the value chain and address a specific target. So a central part of our portfolio is the development of advanced electrolyzer technologies, the hydrogen production in the center. We are developing electrolyzer technologies with minimal or no use of critical materials and with the potential for mass manufacturing. High volume storage of hydrogen is of course also foreseen. And as TNO, we thus perform research on hydrogen storage in cell caverns and abandoned gas fields. We are also working on the development of smaller storage facilities, for instance in vessels. On the North Sea, we will have to convert our traditional offshore oil and gas production infrastructure. And TNO, we are working on the integration of hydrogen production with offshore wind and solar. So where we try to make use of as much as possible of the existing offshore infrastructure. And just recently, we installed the world's first offshore electrolyzer on an offshore platform to get confidence in this type of technologies and also to get experience with what it means to have an electrolyzer on an offshore platform and what comes with it. As you know, the Dutch economy is highly dependent of fossil-based chemical industry. So now we go into the end user part. And TNO is a partner for the chemical industry in the Netherlands, but also abroad, to shift to hydrogen and electricity as main power source and feed. To support the transition, we give advice both to different industrial sectors as well as government on policy, business models, and ecosystem development. So altogether, this gives an overview of what we are doing in the hydrogen value chain. TNO has a long track record in hydrogen research. It goes back for decades. Over time, we have invested in dedicated research facilities, both for research into electrolyzers, conversion and storage, application of hydrogen in different domains. Examples are our Veen lab for electrolyzers, our Stack Test Center, our energy storage lab, power lab for automotive, and our field lab for industrial electrification. Over the past years, we have executed numerous research projects over the entire value chain, as I showed you before. And over the years, we have also executed more than 50 techno-economic market studies. So I would like to present a few of the research projects we have worked on recently or are presently still working on to give you some flavor of our activities in hydrogen. So the first example is North Sea Energy. This is a shared research program. It's an R&D program on the energy transition and system integration on the North Sea. As I mentioned, we did install an electrolyzer on an offshore platform, but we are looking into technical options for linking offshore oil and gas infrastructure with wind, with looking at platform electrification, opportunities for power to gas, opportunities to gas to wire, and also opportunities for storage and carbon capture. This kind of shared research programs we do together with a lot of stakeholders. In total, more than 30 stakeholders are involved. And it involves multidisciplinary research and development. It's not only about technology, it's also about what is the social contract that we have. It's about regulations, it's about ecology and environment. There has to be a business case, of course, but it's also, we are looking also at what is the effect on labor market. How do we get sufficient people with the right skills at the right time, at the right place? And what is also performed by TNO are macroeconomic impact assessments and energy system integration modeling to simulate the effect of investments made. These are large scale. This is a large scale program with a very specific target, of course, to develop this North Sea energy system. Some other examples. So an example is the HI3 program. And in this program, we work together with Jülich in Germany and Dana, and we analyzed the potential of the reuse of existing natural gas infrastructure between the Netherlands and Germany. So this infrastructure is currently used for export of Groningen gas from the north of the Netherlands towards Germany, with production coming from of green hydrogen from offshore wind, electrolyzers at the North Sea. The vision is that in the future, the same pipeline system will be used to transport hydrogen into the Ruhr area in Germany. Again, this research is performed with 18 industrial partners from Netherlands and Germany, and this research is publicly funded. Another example is Nord 2. This is a large-scale hydrogen production from offshore wind and onshore electrolyzers in the north of the Netherlands. The project aims at developing in the end, a 10 gigawatt offshore wind park in the north of the Netherlands with onshore hydrogen production from electrolyzers and transport via the existing gas infrastructure of Gasunie, the Dutch gas distribution company, towards major demand centers in the Netherlands and Germany. This project has a timeline between 2027, when the first wind park should be built, until 2037. So it also shows that these projects have a long horizon. TNO in this project is executing the feasibility study together with DNV-GL. And this includes technology assessment, market assessment, energy system modeling again, and also the business case development. Another example of where we are working on the hydrogen production. So what we did together with a consortium of parties under the guidance of the Institute of Sustainable Process Technology, we developed a conceptual design and a cost estimate for a gigawatt scale electrolyzer plant. This plant should be ready for startup in 2013 and deliver hydrogen at a cost below the current cost levels for the manufacturing technologies. So the picture shows the possible layout for such a gigawatt plant. And as TNO, we studied what are the limitations in scaling up the current electrolyzers. And we wanted to better understand what is the potential for stack-up scaling, so to develop a view on future cost levels of such a plant. And the developed models that we have for the cost analysis of this type of gigawatt plants are validated with test results from our electrochemical laboratory in Patton, the Faraday lab. Some examples of storage projects we have performed. One is a high under, and the high under project focuses on the large-scale underground hydrogen storage for Europe. It's on a European scale, and we work together with institutes and companies from different countries in Europe. It gives the project assess the potential of hydrogen storage in underground salt caverns in this case. So benchmark is performed of large-scale seasonal hydrogen underground storage against other competing technologies. And we do assess the requirement for below and above ground plants and process technology that is required to operate such a storage. Individual case studies on hydrogen underground storage are performed in France, Germany, Romania, Spain, the Netherlands, and the UK. It gives us a really good insight in what's the present state of the art and potential of hydrogen storage in salt caverns. Another option for large-scale hydrogen storage is in abandoned gas fields. And well, that is the second project below. Apart from salt caverns, there we also looked at how to use depleted gas fields on and offshore for storage purposes. Again, multi-party and multidisciplinary, where we also look at societal embeddedness, regulatory frameworks, and risk. Some examples of power generation. So at the demand, going to the demand side, in the development we have a very specific development I feel we know of course that there is a possible application of hydrogen in trucks, and well, we all know that in the end, of course, fuel cells could be used there for truck use of hydrogen in trucks. But what we are developing in TNO is also more intermediate technology in our view to use hydrogen for internal combustion engines. So, and this could be an interesting intermediate step. We're looking at combustion concepts, the power densities, the efficiency of such a combustion engine, both the tests for stationary and transient. Look at what is the need for after treatment if you go to hydrogen combustion, and you have to, of course, make adaptations in your fuel injection system. And you have to take preventions for certain effects if you go to hydrogen. So crankcase ventilation, backfire prevention. So what is this? This is also performed for a consortium of parties with a larger truck manufacturer in the Netherlands, and a possible interesting application of hydrogen in the mobility sector. And the last example is H2 Magnum. Here we looked at use of hydrogen as a fuel for a gas power plant. So we investigated the feasibility of conversion of one of the 3 Magnum 440 megawatt units in Eemshaven in the Netherlands. Gas power plants. What would it mean to convert one to hydrogen? And came out that, and in the end, that one could run on hydrogen, reducing the emissions with 4 megatons of CO2 per annum. We performed as TNO the energy market and systems analysis, and we did a design and evaluation of the large-scale value chain, where production of hydrogen is combined with CO2 capture, transport, and permanent storage. So, to conclude, as the projects presented show, the development of industrial ecosystems, that is really vital in driving innovation in hydrogen. You cannot do this alone, you have to do this together. And I would like to end this presentation by inviting all attendees to join forces, because it is our firm belief that only through large-scale and international collaboration we will be able to tackle the massive challenges we face in the time we have. And thank you for your attention.
Thank you, Peter, for this detailed overview. Now, Thomas Hajonides.
Thank you for introducing me, and thank you for the opportunity to share some of our insights in hydrogen trade. And I'll do so by not only sharing some general statements or insights, but also give you a teaser on very specific content insights that we created and came up concluding in the past few years of research. My name is Thomas Hajonides. I work as a research consultant within TNO, and I work on a variety of topics that all boil down to supply chain complexity and collaboration. And I'll share with you these 3 insights that I promised you. Share my screen. There we go. Hydrogen trade, what matters from an EU off-taker perspective? And that is obviously the perspective that is much needed, because if we produce a lot of hydrogen elsewhere, and hydrogen has a clear purpose for its use, then one of these off-taker hubs will be Europe, and also the Netherlands specifically. The major role for hydrogen in Europe has already been addressed multiple times. So I've put it into some numbers. The current use for hydrogen is a bit more 300 terawatt hours per year in different sectors, mainly refining and ammonia. That is currently done in the Netherlands, as well as Germany and Belgium. As we call it, this is the ARA cluster. This is a highly integrated chemical site, but also beyond these locations. And we expect that in Northwestern Europe, there will be a lot of different locations where hydrogen will be an option for decarbonization, which does not need to be the option of choice in the end. But currently in this potential off-takers scan, the visual to the right shows you that there's a wide variety of locations that might have off-taker potential. The details for the type of hydrogen quality, as well as the off-taker specifications, can be found in the publication that is added at the end of this presentation, as this is a scientific publication as well. Moving forward means that we will be needing the hydrogen trade relationships that can be established between African countries and European countries to secure our reliable and stable hydrogen supply. The Netherlands, as well as other Northwest European countries, have access to a large potential of hydrogen production ourselves, mainly through utilizing offshore energy, harvesting through offshore wind turbines. But that will be an intermittent profile, as well as perhaps not cost competitive enough when compared to African imported hydrogen. Therefore, a reliable supply chain is crucial for investment decisions. And as known by many of you already, besides African countries, other countries might be of interesting exporting towards European countries as well. For example, the South African regions have promising potential, as well as the South American regions like Chile and Argentina. But I'll focus on Africa in this example, but it should be mentioned that there are many other competing regions that may be potentially exporting towards Europe as well. What is also important is to realize that when talking about hydrogen, we're not talking about hydrogen molecules only. We talk about ammonia when hydrogen is combined with nitrogen. We talk about methanol, a commonly used molecule already. We talk about, for example, liquid organic hydrogen carriers as a means to transport the hydrogen. But we also can talk about importing hydrogen-based molecules like diesel, kerosene, ethanol, and other commodity scale trade streams. It's important to realize that when talking about hydrogen trade, we may actually mean methanol trade, or we might mean synthetic kerosene trade. So in my future 3 points of interest that I want to share with you, I will talk about hydrogen, but please be noted that other types of hydrogen-based molecules can be inserted as well. When talking about hydrogen trade, we need a supply chain. And obviously the supply chain can be covering, for example, the production of hydrogen, the logistics, as well as the end demand centers, but it can also be stretched towards end use, and then we would need to add intermittent distribution as well. As Peter Paul has introduced to you, the Netherlands is an excellent location for importing large-scale hydrogen and then feeding or distributing it towards other European countries. But I will focus only on trade up to the Dutch industrial sites where large-scale storage is possible. The distribution beyond, I've left out of scope. The 3 topics of interest. I'll talk about the essential role of security of supply for the Dutch and European off-taker perspectives, also about carbon intensity and about import cost. We believe that these 3 items are crucial in establishing trade relationships. Let's start with the security of supply. As I mentioned before, import may play a crucial role in flattening out intermittent local hydrogen production profiles. For that role, it is much appreciated if that hydrogen that is filling these gaps is available at the times that the European industry or other off-takers are needing it. We will therefore be needing a lot of logistics optimizations for ship transport to operate and arrive right on time. But that is not the security of supply that I will be discussing. I will be discussing the combining of different production assets for hydrogen. And that would start with a reliable supply of renewable electricity. And an example there is the opportunity to use the land available in African countries combined with different technologies that are most suitable for harvesting that renewable electricity, and combine those. For example, use concentrated solar power in combination with photovoltaics, and adding a battery will help you to create a stable electricity supply towards your electrolyzers, and therefore create a stable hydrogen output, which allows you to run stable ammonia or LOHC carrier production processes, and that leaves out the logistics challenge that we are very familiar with in other sectors already. So one of the drivers for establishing trade relationships from the African continent is the availability of complementary technologies and availability of land. Transferring to hydrogen, to carbon intensity as a driver or as a point of interest. It should be noted that we do not have clarity on the specific certification schemes yet, but let's assume that we should not use fossil power to power green electrolysis production. But we do need treated water. And we also need, if we want to make carbon-based molecules, we need a carbon source. These are different feedstock flows that are critical, and you could transfer the security of supply point raised to this topic of interest as well. But I want to address only the carbon intensity that is addressed or that is attached to the molecules that is in the end imported. It is crucial that the carbon intensity of these imported molecules is as low as possible to comply with future legislation and decarbonization targets. The last point to share with you is the import cost. And the common used term for this, levelized cost of hydrogen, is built up the costs for each supply chain element individually. By dividing the total amount of costs with the total amount of ton hydrogen over the life cycle of all the assets, we arrive at certain cost indications for hydrogen import. And what we see is that many different countries will be competing with each other on their lowest levelized cost of hydrogen. Important as well on this topic is that there are many drivers for this cost that can drive the cost down or up. Major cost drivers obviously include the cost of renewable electricity, but also economies of scale effects can drive down these costs. And as previously mentioned, large-scale projects might be feasible to develop in African countries, that give countries in Africa a major advantage over other countries around the world. The last disclaimer on this topic is that if the hydrogen market becomes a commoditized market, the lowest cost production regions will simply be the regions that benefit the most of market clearing mechanisms, which means that there will be a clearing price for hydrogen on a global scale. And that means that the off-takers will pay the spot price for hydrogen instead of the lowest imported price, unless public-private agreements are made and bilateral trade establishes that gives you the competing edge to develop trade relationships between African countries and specific off-takers in Europe. To summarize, I mentioned that supply of hydrogen-based molecules from African countries to Europe is crucial to have a reliable and stable supply of hydrogen-based molecules. And for that, many different supply chains are possible in the near future. And 3 points are crucial to establish these trade relationships: stable security of supply, lowest as possible carbon intensity, as well as competing import costs. Thank you for your attention, and happy to get in touch with you. Feel free to contact Peter Paul for any follow-up, or Peter Paul can share my details as well. Thank you for listening in, and happy to take any questions or thoughts from your side.
Thank you, Thomas. Now we'll go to questions. The first question: which regions are most interesting for imports of hydrogen for the Netherlands? It's not specified to whom, so you can take it.
I can take it maybe more general, and then Thomas can add his thoughts about this. So I think it's not about, first of all, I think it's not about the Netherlands. I think what I showed is the Netherlands is also a hub to Northwestern Europe. So we have to look at what are the regions that are most interesting for Europe, I think. And of course, there will be also a lot of hydrogen available within Europe. That's also something we have to be aware. So there has been, of course, with the war on Ukraine, I already said that there is a new the levels are rise. The ambitions have become much larger, and urgency is also there. If you look what is the offtake that is foreseen for hydrogen for Europe, then it's about, well, you can say that maybe about a third of the hydrogen demand will be served by European production. It can be both in the Nordic countries or in Portugal and Spain. There is certainly potential for the northern African countries, Morocco, Algeria, but there is certainly also interest to import hydrogen from the Middle East, and that can be done also by pipeline then. And then of course there are certain regions further away. There are talks with Australia, a lot of sun, infrastructure available. Chile in Southern America, and then of course coming back to Africa, and there is a lot of potential, of course, in Africa, and there are a number of countries are preparing and investing already to become a player here.
Thank you, Paul. So
add nog something to this?
Yeah, please.
Thank you, Peter Paul, for starting off the answer. There are two things that I would like to add. One thing relates to infrastructure. The other is to lowest risk investment climate. From our past experience and research, we clearly see the advantage of transporting hydrogen in gaseous form through pipeline, for example, from Morocco to Europe. But that type of infrastructure is not put there overnight. If you're able to establish a pipeline connection from the African continent towards large-scale industrial users in Europe, you have clear beneficial advantage. That will be more difficult for ship transport, although ship transport is more flexible. But also ship transport needs infrastructure and jetties. Basically, if you can establish the pipelines, then the North African regions have a clear benefit. If that takes too much time to establish it, then shipment of hydrogen carriers can be first to go. The last topic that I want to answer this question with is the lowest possible investment risks and investment uncertainties that you can achieve. Because scaling up large-scale projects requires a large amount of investments that can only be done in the environment that is most friendly and most attractive to investors. And that means that many other topics that are not addressed here will come into play when people start making final investment decisions. And my knowledge about African countries is not sufficient to go into detail on this. But that is a clear advantage that we commonly see addressed by decision makers. Thank you.
Thank you, Thomas. Next question. In terms of ocean transportation of hydrogen, could you provide us with details on the possibilities? Is a conversion to ammonia as cargo the best solution?
I can take that question. That depends on how you define best solution. That is the clear scientific answer to this question, but that will probably not suffice. So I'll add a bit more details. Ammonia, when in the end used as ammonia, is a no-brainer for hydrogen import, as that is clearly more cost beneficial than importing hydrogen or producing hydrogen locally against higher electricity costs and then converting it into ammonia in, for example, European countries themselves. Importing ammonia from African countries with green hydrogen as a basis is currently already considered the most easy decarbonization route in European countries. But cracking back ammonia to have hydrogen as a hydrogen gas is more or less breaking even on the cost part when comparing it with LOHCs. Ammonia is a clear advantage when compared to liquid hydrogen. It's the general order of things that we currently see.
Thank you. Now, question for Kal'air. Has there been any memorandum of understanding between the Netherlands and South Africa signed until now?
Thanks so much, Hans. Yeah, there are some MOUs that has been signed between the two countries. As we know, if you go back to the past stories, you can know the relationship, South-South relationship, the one actually South Africa have with Netherlands. So we are working closely. We are working closely between the two countries actually to many projects, and then hydrogen actually add value to what we are going to. Yes.
Thank you. Next question. We are seeing numerous projects and investments in the subsea pipelines for hydrogen. Can existing pipelines, gas pipelines, be used for transporting the hydrogen? And if not, why? Who wants to take this one?
Sorry.
I can
Okay.
take the question based on research that Peter Paul shared. The general answer is yes, but it is highly dependent also on the pipeline-specific inspections that show the material corrosion behavior when adding hydrogen. Admixing, so adding hydrogen, for example, to a natural gas flow is without any problems until now, based on our research, done up to 20% of hydrogen in your natural gas stream. So based on research project that Peter Paul shared, many of these reports are available for the general public. You can find these findings as well. So let's stick with that. It's more detailed, should be read in detail in the reports.
Thanks, Thomas. Again, question for Kal'air. Is hydrogen a bearer of hope for the economy and the future life in Africa?
Thank you. What I can say actually, hydrogen, it's our new energy transition. That's in shorter that we are saying just energy mix transition, but hydrogen, it's going to be attract all our living society. Why are we talking about the living society? Because hydrogen will attract. Right now, actually, we know we're going to the carbon net zero, to decarbonization, actually. Those are the parts, actually. Hydrogen are trying to create many jobs. Only South Africa alone, we are going to over 30,500 jobs, actually, between now and 2025, when we're going to launch the hydrogen. So hydrogen will eliminate many when it comes to poverty. We're going to bring Africa energy transition in a better living. So that's exactly what we are looking for hydrogen. Hydrogen, it's going to develop economy to each country. Those actually are capable to produce it in Africa. So what we're talking, our climate is good. Our financial security risk, it's good right now. So we should be moved and contributing for economy to our living society. Yes.
Thank you. Another question for you. New studies show that Africa has the capacity to create 1 trillion in green hydrogen annually by 2035.
Yes.
What countries, in your opinion, will take the center stage to make this happen?
Thank you. It's we're talking about, it's going to be a task force. A task force actually that we're looking. We're not putting finger in one country, because hydrogen is a major task. It's a force that we need to be all of us together in one shape. So we're looking about Netherlands are there, the Dutch actually, Netherlands and Germany are there to promoting. Those are the two countries that actually are putting more potential and more innovation through to this kind of technology to produce hydrogen in Africa. So that actually we're looking about, we will combine all countries. We're talking about the Dutch side, we're looking about the French, we're looking about the Belgians, and we're going back also to the Australian. Actually, they are more involved in Africa. So, but in Europe, we're talking about is only the country that I see, they're putting their hand on it is only the Dutch side and the French, including the Belgians.
Thank you. Question for Peter. Regarding the utilization of hydrogen, what would you say are the technologies or applications to watch in the future?
Well, that's a difficult question to watch which applications. I think that if you go, if you look at the demand side, and there will be the first demand, as Thomas also showed, is replacement of existing use of hydrogen in chemical industry and in steel making, for instance. And that's the replacement of hydrogen already used now, but which is now gray. This will shift to green. So then, what we have to look at is which companies are making investments in going in that direction. And then what we see, the first large-scale uses of hydrogen will probably be in chemical industry then also. So further demand will come from chemical industry, from the steel industry probably, and there will be also demand from shipping. And then if you go towards shipping, you go to let's say large volume shipping, and then there is also not, there is a debate in which direction that will go. And there are presently there has been, or recently there has been a shift towards LNG for long haul shipping partly. That was an important step, but it also required time and investments. What we will see is a shift towards other fuels for shipping, and this market will also develop over time.
Thank you, and we will wrap up this webinar with the last question for Thomas. What is the main request regarding the regulations for trade between Europe and Africa?
Clearly related to guarantees of origin. To what extent does hydrogen count as green hydrogen when imported from a country that, for example, uses partially green electricity and partially non-green electricity for its green hydrogen production, connected to what type of substitution is possible between different moments in time. So basically importing green hydrogen from, for example, South Africa at time 1, using gray hydrogen at time 2, but on a system level being equal. These type of guarantees of origin and truly green hydrogen discussions and debates on the regulatory regimes are most pressing at the moment, based on my research until now.
Thank you, Thomas. And this is it for today. I want to thank the audience and the speakers for their effort. Please don't forget to tune in tomorrow to our new webinar with Jack Velferis and Margot Ann Warner. Also, please like, subscribe, and share. Thank you, and see you soon.